So I'd like to then kick off with our first presentation. Our first presentation today is from Critical Manufacturing. Dave Trail will be the speaker, and his presentation is how the manufacturing digital twin can open a new window into your plant's operations. Dave?
This one's fine. Yeah. Hi, nice to meet you. Hope everybody had a good night last night. I hope everybody's kind of awake this morning. I tend to speak fast most of the time, especially when I get a little bit nervous. So if I start speaking very, very quickly, especially for some of you where English isn't your natural language, please just raise your hand and that'll remind me to slow down a little bit. So a little bit about Critical Manufacturing. We are a large MES company based out of Portugal with offices all around the world. We've been in business for 10 years, great success within the semiconductor and medical device assembly industries, as well as in electronics. I joined the company a little while back in charge of their SMT and electronics business unit. I've been in electronics assembly for 25 years. I've sold just about every type of equipment that you see in most manufacturing plants and most SMT lines. So I know a little bit about the process. Today we're going to talk about the digital twin and how that might be able to improve your manufacturing operations. Now, why is that interesting to people? Why are people looking at digital twin or digitization? Primarily because there's a lot of value that can be created with looking at these technologies, both by the customers who are utilizing them, by their customers who are reaping the benefit, and by you vendors who are perhaps selling some of this supporting technology for digitization. And whether you call it Internet of Things, Industry 4.0, Industrial Internet of Things, China 2025, there's a lot of different ways to talk about this. For the purpose of this presentation, I'll use Industry 4.0 primarily, but I'm referring to all of the other terminology for the same activity. So in talking about Industry 4.0, we spent a lot of time yesterday and are getting started today on what is Industry 4.0 and what will enable Industry 4.0. As I see it, Industry 4.0 is enabled by having rich, granular, accurate connectivity across all the machines, equipment, people, and processes on a manufacturing floor that are gathered in real time, that are complete and contextualized. And all of this creates what I like to think of as an integrated fabric of device, data, connections, processes, and people. This is how I look at Industry 4.0 working together to benefit the industry. The next topic leading into where I'm going with digital twin is the concept of cyber physical. So what is a cyber physical product or a cyber physical production piece of equipment? A lot of this has to do with some of the IIoT sensors that are entering the market. And those are Industry 4.0 sensors and data collection units all in one. They represent a part of the digital twin and part of the thought process of what makes a digital twin. However, they are separate. But while they're separate, they're also connected by systems that utilize both of those separate pieces to provide a value to the customer. So what is a digital twin? So on the left, you'll see a drawing. This is the original drawing that was part of a paper that was written by Dr. Michael Greaves of the University of Michigan in 2002. And this representation is the one that he placed in his paper describing what he envisioned as the digital twin. Now, when he started talking about this, he had a lot of different names for it, and it wasn't until about 2012 that the term digital twin really stuck. But what it is, it's two systems a physical system that's always existed, and a new virtual system that contains all the information of the physical system. That includes all the data, all of the geometries, all of the items in the physical world represented digitally. Now, a lot of people want to talk about digital twin, and there's a lot of different ways to describe it, and there's a lot of different ways to talk about it. However, it's not very well understood in our industry. In the design industry, it's been around for a long time, but a lot of people think, okay, so how does digital twin affect me? I manufacture printed circuit boards, or I make electronics products. That's great on design, but how does it help me build my product? So there's a lot of education that needs to take place, and even within the MESA Association, part of the minutes that was taken out of one of their meetings basically outlined that we need more education about digital twin. We don't quite understand it, so the definitions need to be worked on a little bit better. And that's something that they've been working on. As I see it, the digital twin supports the life cycle, from the cyber physical system all the way to the manufacturing cyber physical system, all the way through the product life cycle. From concept, development, design, production, use out into the customer's fields, improvements or returns as they may happen, feeding back into the concept, constantly adapting the product to beneficially support their customers. So what is a digital twin? Obviously, it's an aggregate of an entire line of equipment twins. It's the aggregate of all of the models of the product itself. It's an aggregate of the model of the processes that take place on your manufacturing line, containing all the specifications and performance data that pertain to that particular product. I mentioned MES in this slide. I'll discuss this a little bit more, but a lot of people perceive MES as the very first form of digital twin for manufacturing. I'll get into that a little bit later. But, okay, so we've kind of described digital twin, but what does that mean to you? What are some of the potential uses for this? It can be used to help you design your plants, do your line layouts, run simulations on the product, see the product being created in real time, manufactured in real time. You could use it to analyze trends and to benefit your performance and make your operation run more efficiently. In some of the earlier presentations, we talked about digital thread. What is a digital thread? Digital thread, as described by MESA, really pertains to all of the communications and data that exists throughout the product lifecycle, from design into production, into the customer's usage and back. The digital thread serves the digital twin through allowing you to do modeling, predictive maintenance, things like that, fed through data feeds, et cetera. And the digital twin acts as an intersection within that digital thread, providing context to that data stream that's being created, and it allows you to organize that data into data sets. What we're seeing right here, this is an example of digital thread. This is actually taken from one of our customers who's in the aerospace field. And really what it's talking about is, this product life cycle, the voice of the customer, quality requirements, work instructions, all the information that is carried along with the product as it's built, all the way through to where it's delivered to the customer. And while we may not have warranty claims that we have to satisfy, there are always lessons learned and things like that. All of those feed back into the digital thread, improving the product, and it becomes a circular type formation as it pertains to the product. So what can I do if I have a digital twin? Digital twins can be used to increase the visibility on your manufacturing floor, obviously. It allows clarity of focus. It allows you to be able to look at exactly what it is that you want to look at on your line and provide contextual, not just information, but visual feedback on what it is that you're looking at and how that pertains to the particular problem or performance improvement that you're trying to work on. It helps you decide where you're going to allocate your resources, because you can run simulations once you have a digital twin that's intelligent enough to be able to run simulations of your product build. You can run through multiple iterations, identify the problems that may arise before you actually start building the product to help you decide where you're going to allocate your resources, or even where you're going to put your equipment on the manufacturing floor. All of this improves the reliability of your product and allows you to hit the floor running much more quickly when you do, in fact, start building your product for real. It provides an early warning system, visually recognized. So instead of having to go out on the factory floor and look for that flashing red or yellow light, this can be a feedback that can be seen back at your office or on your tablet or cell phone, et cetera. It also provides a mechanism to utilize the digital thread in augmented reality and virtual reality. We'll touch on that a little bit later. And last but not least, it allows some companies to enter into new lines of business. And that can be described in a couple different ways. I've seen customers that have really utilized digital twin as a way to gather new customers. You know, when you bring a customer in your facility and you're talking about what it is that you do and what you do well, utilizing a tool like this is a wow factor that may pique the interest of some of your harder to gain customers. Also allows you to utilize that data in other avenues to benefit your business. So why do we care? We care because the digital twin is going to be something that is growing. It's something that is being widely accepted within the industry. It's being predicted by IDC and Gartner that 50% of the large industrials will be utilizing digital twin by 2021, achieving a 10% improvement in effectiveness. When you start talking about a 10% improvement in effectiveness, 10% may not sound like a lot, but when you're running a $100 million or $10 billion organization, that 10% really adds up quickly. And most of the companies that are using it are going to be seeing significant gains in innovation, success, and productivity. So this is Dr. Greaves, as I mentioned earlier. This was at a seminar that we did a while back. And I won't exactly get into what he's saying there. You're welcome to read that. But what he's talking about, the digital twin that we're utilizing on the factory floor, it's embedded, the intelligence that's embedded in the physical system is represented and linked to the actual physical asset. So that pretty image of a pick-and-place machine or an assembly line, it's not just a pretty picture. It has data embedded in it. It's an intelligent image that can be utilized. So this is another version of the digital twin. On the left, obviously, is the physical. On the right is the virtual. You see that there are arrows flowing in both directions. A digital twin is a living entity. Okay, it is a live entity, both receiving actual data from the production line and providing information, instructions, and benefits on how you can improve your processes back to you within the production line itself. What I'm showing here is 3 different types of digital twins. Digital twin, as I mentioned before, is very well known in the design part of the process. It's very well known through CAD modeling and things like that to be able to work out the design before they actually start sending it to you to build the product. Digital twin also is represented in the virtual assembly line world, where you're simulating and doing a twin of the process that you intend to do when you build this product. This helps in planning and in validation. And then lastly is in manufacturing execution. And that's the loop that I'm trying to tie together here, is how digital twin, which is widely used in design, can also be used in manufacturing to benefit you and help you be more successful in what it is that you're trying to do. The problem here is there's a lot of different definitions of what a manufacturing execution system is. Really, as I mentioned before, an MES, or a manufacturing execution system, is and was the very first form of digital twin for manufacturing. It was defined as such by AMR Research in the late 90s as a functional layer of information technology that links business planning and shop floor control systems to deliver a manufacturing and achievable and realistic production plan. That sounds a lot like what I was describing about a digital twin, but this definition was placed by AMR Research in the 90s to describe an MES system. And I'll let you read the others later. One of the quotes is from Mesa, the other one's from good old Wikipedia. So what are the main objectives of an MES? Most of us know these answers, but I'm going to go through them anyway. An MES should be used to increase your productivity, increase your throughput, lower your costs, improve your quality and your yield, make your maintenance cycles much more efficient, as well as lower your costs of labor in manufacturing a device. It's designed to improve the quality, okay, by monitoring what's happening on your production line in real time, managing any exceptions that may occur, improving processes, and of course provide traceability and all of the requirements from your customer. MES also provides a great deal of flexibility, assuming that you pick the proper MES system. Okay, there's some very old systems out there that weren't designed with some of these newer technologies in mind. The MES system by Critical Manufacturing was built with the latest technologies, with tomorrow's technologies in mind. As far as I know, we're the only company that does have Industry 4.0 in both our mission statement and our corporate directive. Okay, so Industry 4.0 is something that we embrace. We embrace it as something that customers shouldn't view as, oh, that'd be great. We see it as something that is mandatory. We see it as mandatory for any company that is going to be successful moving forward within our industry. So I talked about MES as really the first form of a digital twin. How does it do that? The MES maps all of the manufacturing processes, all of those physical processes, materials, BOMs, equipment, the flow of product within your line, all the operations. You have location information, all the engineering data is based in there, as well as all of your business processes that you've laid out in building your product. MES, as I said, was the very first form of the digital twin to provide visibility, controlling documentation, and driving optimization. Problem with that is most people look at Industry 4.0 in silos. They see MES as one component of it. I have an MES, I just need to add some IoT, to my factory floor, and I need to create a digital twin. And oh, by the way, I saw that one of my competitors is using augmented reality, or I saw it on TV. How do I put that onto my factory floor? Well, all those things are really cool and really great. They will never be effective unless they're all encompassed in one system. The Critical Manufacturing MES system was designed to house all of these different silos in one MES system. And if you're on the market or looking at your or any other MES system, you need to find a way to have all of these encompassed in one system as opposed to different silos that are trying to communicate with each other more times than not effectively. So the basis of my presentation is on digital twin. This is one of the very first visualizations of a digital twin. Okay, a lot of us think of it now as a pretty 3D chart or a model of what an assembly line should look like, which is true, but it's also true that it could be a flat document, okay? Because this is showing what's happening on your lines. It's showing uptime, it's showing yield, it's showing what's being produced, all in a visual format and as a digital representation of what's taking place on your manufacturing line. That was one of our first products in 2009. In 2011, we decided to step it up a little bit. Okay, so what we did is one of our large customers that you see on the right, it's a semiconductor back-end customer that has 1,500 machines producing product in their factory. We took what we had done before and took those boxes and did a floor layout of where those pieces of equipment are. So we've kind of done a little bit of a leap from, all right, so here's what's being built, to, all right, so here's what's being built and here's its location on the factory floor. You'll also notice that it's still flat, but it does provide a little bit more data than looking at a spreadsheet on a piece of paper. This allows a floor manager or a line manager or even senior management to be able to get a real-time view into what's happening on their manufacturing floor. Then in 2017, we took a pretty major leap from having those flat but accurate representations of what's taking place on the factory floor and made them 3D. What this provides is not only a view of the factory floor, but it provides that view in a format that is more easily recognizable to what you would see actually out on your factory floor. It takes a lot of the thought out of it, and you can really simulate what your floor is really doing in real time. But these are not just pretty pictures that were designed by some CAD person. These were actual real information sources. Whereas you can click on each piece of equipment and see what's happening at that particular piece of equipment at that time, what its run rate is, what its yield rate is, et cetera. And this can also be used to model people or some of the AGV robots. It's really a window into what's happening on your manufacturing floor. I mentioned before that I believe that all of this should be encompassed in one MES system. In order to do that, we have to provide the capability to create those models. And when we first started working on this, we devised a system that would allow you to do some 3D modeling by yourself using some three-dimensional drawing tools, and you could get as creative as you wanted with this. You could simulate them just as boxes, representing, green boxes are pick-and-place machines that are running. Red box is your reflow oven that is down for whatever reason. It's providing some information, but it's obviously could be improved upon. But once again, these are still smart objects modeling your factory floor, a digital twin of your factory floor. From there, we took the next step and we improved the amount of data that was being displayed on these representations of your factory floor. People started using it to configure what their factory layout is because they were able to simulate production and say, all right, what happens if I move this line over here as opposed to leaving it where it was? What happens if I take the tool crib and move it a little bit closer here? And does that reduce the time to improve upon maintenance or replenish my feeders, things like that? You're able to simulate these things in real time, providing beneficial information to you. Other things that have been done using our technology, I guess prototyping of, all right, so if I buy this SMT line, this is what it's going to look like on my factory floor. Do I have enough room around this? What is the flow of production going to be if I locate this assembly line in this location? Is it the right place for it, or do I need to rethink this? It takes the mental visualization that we all do in our mind and make it a little bit more tangible and usable. in order to make those boxes or those models intelligent, you need to be able to get the information into them. And there's a variety of ways to do this. And we've talked about various methods, various standards. It could be as simple as uploading an Excel spreadsheet of the data on regular intervals, a direct interface into a database of a piece of equipment, using some of the older standards like SexDems or CAMX, or maybe even some of the newer standards like CFX. Being able to get that data into these models is what makes these models and these twins intelligent. So now that we've made these models a little bit more granular, a little bit more realistic, and we've added data to them, we start to see that this model of our factory floor starts to look a little bit more like what my real factory floor looks like. And I could start taking deep dives into our production process. In addition, I talked about some of the other business possibilities. This is one of our customers in China that actually displays their production and their digital twin of the production process in their lobby of their offices. That way, when their sales guy comes out and is talking to customers, he's able to say, all right, so on this assembly line, you notice that we're running these products, and I can click on it, and here's our yield rate on this, and here's what we're achieving for uptime. Here's where we are in this run. It becomes a valuable tool, not just for the manufacturing people, but everybody in the company. We realized that it's great to be able to build equipment and machines using drag and drop boxes and spheres and circles and cones and things like that, but that takes a little bit of time. We thought that there's probably a better way to do that. So what we've started to do is work with a lot of the equipment vendors who can provide an actual model of their piece of equipment that provides a better representation of what we're talking about. And ultimately leading into something like what you're seeing right here is the digital twin representation and the physical world very closely representing each other. And also what it does is it takes those pretty colored boxes and adds a little bit more detail to them, makes them a little bit more realistic, while still maintaining the intelligence that's behind each of those pieces of equipment and the processes running behind them. Therefore, if somebody wanted to reconstruct a line, they would just be able to click from a library on the right-hand side of that file and drag and drop it into place. So we do provide a pretty large library of existing equipment models, and we work with our customers as they develop new ones to be able to utilize them. So in addition to digital twins, we also see a great need beyond just a digital twin model of what's happening on your factory floor, but we want to be able to see what's occurring, not just in a model, but in various methods. We want to be able to create our own graphical user interfaces. We want to be able to have graphical interfaces that are usable by different people within the company. But we don't want to tie up IT by saying, all right, I need this particular report to look like this, and I need it by next Tuesday. And the IT guy says, I can't get to that right now. My server's down. I got to do this. I'm busy right now. So we've made designing our user interfaces as easy as drag and drop. You can design them however you want to do. You're able to display them in a lot of different formats, whether they be circular pie charts, line drawings, graphs, etc. Able to add color keys to them. But most important is as you're designing this, you're able to very quickly link that to a particular part of the MES system, making this more than just a drag and drop, but very quickly creating a live document that is a vision into your production floor. And even beyond that, we realize that sometimes you don't have time to do that. Sometimes you want to be able to use what's there. You want to get up and running very quickly. So we do provide what we call business intelligence cards. These business intelligence Cards are a variety of different formats that can show a lot of different things, such as what's my OEE on my contact printing machine 1, what's the mean time before failure, what's the MTTR, what's my state timeline been like, how long has this piece of equipment been up or down, what's the health of the piece of equipment, et cetera. And this can be done for a variety of different items on your factory floor. So once you create your digital twin of your factory floor, instead of just clicking on a box and it opens up a stale format such as this, okay, this is my contact printing machine 1, it's up or it's down, it's blue or it's red. By clicking on that, you're able to open up one of these business intelligence cards that is pre-configured to show you exactly what's happening on that machine at any given time. Okay, this is that window into your production system. Or you could look at the entire factory as a whole and be able to gather all of that information from all of those pieces of equipment that is doing production and look at it as a holistic view of what's happening on your factory currently. Your whole factory OEE, your availability, your quality, your run rates, et cetera. In this slide, maybe it's a little bit hard to see here, but not only are we showing the equipment where you can drill down and see what the OEE and the effectiveness of the equipment is, but what we're showing right here, this is actually the products that are being built on that line. Now, in this particular representation, we show them as floating above the pieces of equipment. We all know that that's not how things are built. But in this particular example, we felt that this was the best way to show the customer that this is what's being built on your line, because otherwise it'd be hidden in the piece of equipment. And these products themselves also have intelligence behind them, meaning that you can click on a particular circuit board and you would be able to see where is this in the process, has rework occurred, what is the traceability number of this, how long did it take to build that board, all of the quality type of information that you may want to get out of a PCB is displayed in real time. And all of that is great, but I run a very large organization that we have plants all over the world. No problem. We can drill down from not only that PCB, then to the machine, then to the line, then to the factory, then to the entire organization all around the world, and be able to drill back down as deep as you would like to go. Somebody else mentioned, I believe the gentleman from Flex talked about, AR and VR is great, but the glasses are expensive and cumbersome. We kind of agree with that. They are great. There is a place for them. However, most of us have a tablet or PC or a cell phone on us at all times. And it would be nice to be able to see not only the quality data and the reporting that's taking place, but also the digital twin on your tablet as you're walking through your factory, or even just giving a factory tour of one of your potential customers. So when I first joined the company, I thought that this was one of the dumbest slides that we had. I looked at it and I said, well, why would you start off with a blurry slide? You might want to change that picture. And it was quickly explained to me that, no, this is actually a really good representation of what the factory floor looks like to most manufacturing people. Okay, they're in their office. It's kind of a black box at times where you know that things are happening, but you're not exactly sure what. You need to pick up the phone, send an email, walk out on the floor to see what's occurring. So your view of the factory floor is somewhat blurred, unless you're using some type of system that does provide a visibility into your factory floor, and that is achieved through some of the analytics that I've discussed, some of the data gathering that can occur, some of the digital twin modeling that can occur on your factory line, taking that blurry picture that you had to go out on your floor to look at and making it crystal clear for you so you can see in real time what's occurring. Not sure how I'm doing here on time. I think I'm running over, but I'll go pretty quick. So what I'm going to talk about here very briefly is the reality-virtuality continuum. On the left, you have the physical world. On the right, you have a digital twin. Digital twin is a representation of the physical world, but they're very far apart, okay? Both beneficial, both very useful. Utilizing both of them is what we call a mixed reality, okay? And within that mixed reality, there's a continuum between each of these separate entities or ends of the spectrum. One of them is augmented virtuality. The other one is augmented reality. Somebody else mentioned augmented reality. Augmented reality and augmented virtuality, as well as digital twin, is part of our core tool. It's not an add-on. It's something that comes with the software. Remember, I mentioned we don't think it should come from a lot of different people doing a lot of different things. We think it should all be housed in one system. And this image right here is just talking about some of the uses of augmented reality. It can be used for work instructions. It can be used for maintenance operations. Also, it can be used by line supervisors to be able to walk down the line and look at a QR code that's been placed on outside of a reflow oven, if you will, and just be able to point their tablet at that and pull up the real-time quality data of what's occurring on that particular line at that particular time. And this is a good example here of, okay, so I'm walking down the line, they're building a product here, I pull up my tablet, okay, so I see we're running lot number WF4, this particular product, our yield for the last 3 days has been 84%, our cycle time looks a little bit low, I may want to look into that a little bit more. And you could do this on down the line. This is an SMT line. Obviously, in a tablet, you probably wouldn't want to see this many pop-ups at once, but this shows that on each different piece of equipment, you can drill down using augmented reality to see what's occurring out on your manufacturing line. And once again, this is core to our MES. So, we're strong believers in Industry 4.0. We're strong believers in IIoT. Once again, as I mentioned, it's part of our mission statement. It's something that we built our software and our company upon, is the rise of Industry 4.0. We don't think it's a pipe dream. We don't think it's a buzzword. We don't think it's something that people are planning someday. We see it as something that people are doing right now. And I probably have a maybe a little bit more firm view on this. My personal view is that if you are not pursuing Industry 4.0 right now, that if you do not have a plan or a strategy or even started on this, you're light years behind your competition because they are. And I see the utilization and the benefits of Industry 4.0 not as being something that'd be great to have. I see it as absolutely necessary. And almost last, once again, we see MES having a very important position within the digital twin world, within the Industry 4.0 world. We see it as a bridge between the actual manufacturing floor and also some of the other more advanced tools that are coming out, some of these big data analytics tools, artificial intelligence. That data and that information has to come from somewhere. All of that's already housed at the MES. We're already connected to the manufacturing floor. So the MES, with all of the benefits that an MES offers, is integral into the entire Industry 4.0 thought process and philosophy. I went a little bit quick on this. I believe everybody's going to get a copy of the presentation. So I included some links on some of the papers that were written on what I talked about. They'll probably be able to explain it much more better than I did. I was trying to run through things. So I encourage you to take a look at those. Also wanted to say thank you very much for listening to me this morning. I hope I enlightened some of you, and I hope I provide a little bit of value.